So now that you have seen how to implement logic using transistors, let's see how you could actually create memory. So this configuration is able to remember a single bit of information that you feed in. Let's see how. So let's say if you want to store a bit 1, which is, this is 1 over here, you feed in to this configuration. These are just your gatekeepers. Don't worry too much about them right now. So the 1 goes from here over here. Now at this point, think about what will be the output at point Q. This guy is gonna turn on when it gets logic 1, right? We just saw. And this one turns off if it gets logic 1. So the output at this point should be 0, right? Because this is 0, this is on, it reaches over here, this one is off, so this one can't be on at the same time. In fact, these are arranged in a way that they can't be on at the same time. So the output over here is 0, and what happens is this 0 goes over here, this is 0. Now think about what will be the output at Q bar. This is 0, so this guy turns on, this guy turns off, and the voltage at this point will be 1, right? Because this VDD will reach over here. So this is 1, and this 1 feeds in back again. So if you look at this, this is like a continuous loop. Once you feed in a number, it will stay in a loop, and the configuration would keep feeding themselves. It's a continuous loop. So now that you have seen what happens when you feed a logic 1 over here, my question to you is, what happens to this transistor? What is the state of transistor M1 when you feed a logic 0 over here? So let's see what happens to M1 when you feed a logic 0 over here. When you feed a logic 0, the 0 will come all the way over here to here. This one is off. This guy turns on. So the output at Q is 1. This 1 feeds in over here again. Because of 1, this guy is off, and the transistor M1 is on. So the right answer to the question was M1 is on.